Okay, hello, welcome to my channel. Now in this video we're dealing with double integrals, alright, and we'll be solving them inside out. So we're just going to be looking at two examples in this video, and then in the next video we are going to learn how to interchange them. So stay right to the end of this video, and please don't forget to subscribe to my channel, turn on notification buttons, and comment, okay, ask questions when necessary, and also stay back and watch our next video. Alright, so let's just go right into it. So we have the integral from 0 to x squared of this function, right, dy, and then the integral from 0 to square root of pi over 2 of the whole of this dx, alright. So you should notice that from here, okay, from here to here is with respect to y, okay, and then after that we integrate with respect to x. So we're just going to start off as it is given. Okay, so to integrate this with respect to y means we are going to be considering this x here as a constant, right? So this is going to be equal to, well, you notice this is, we just put down the first one, which is the integral from 0 to square root of pi over 2. Okay, then integrating this right here, keeping x as a constant, so we just keep the x. When we integrate secant squared of y with respect to y, of course that is just tangent of y, right? So we just put it down here as a tangent of y, because the derivative of tangent of y will give us secant squared of y. So integrating that with respect to y, we are going to take it from 0 to x squared. Alright, so we just take it from 0 to x squared, and then don't forget to put the dx here. Alright, so okay, great. So let's see what we have from there. So we equate these two. Well, this is from 0 to the square root of pi over 2. We are going to substitute x squared, and then we're going to substitute 0. So this is x originally. What we notice is that tangent of, well, in place of y we're going to put x squared, okay, and also we're going to put in 0. That is, we're going to subtract tangent of 0. Of course, tangent of 0 is just going to be 0, so we're just going to stop there, and that is it right here. Now the only thing we have is to integrate this with respect to x, right? So this now becomes just a single integral. So let's do this right here. Okay, that's nice. So you notice that this is x squared. Well, we can do this using a u sub by saying let u be x squared, right? Notice that when we differentiate that, we are going to have 2x. So we can multiply this by 2 and also divide that 2. Okay, so we do multiplication by 1 there. So you notice that 2x dx is going to be the derivative of this inside, right? So when we integrate tangent, of course, we know that this will give us 1/2 of what the integral of tangent function is, natural logarithm of, okay, so let's say natural logarithm of, well, there's no point for the absolute value since this will always be positive, of secant of x squared in this case. Alright, so let me say secant of x squared, and then we have to take that from 0 to the square root of pi over 2, right? So this is from the fact that if you integrate tangent of an angle, let's say u du, okay, this will give us natural logarithm of secant of u, right? So since the derivative of this inside will give us 2x dx, of course, just by making a u sub, this is exactly what we are going to have. So let me clean this. Okay, so let's substitute this and see what we have. So this is the same thing as, well, we put in 1/2 here, 1/2 of, well, we substitute square root of pi over 2 in place of x here, right? So this is going to be then the natural logarithm of, when we substitute this here, we're going to have secant of x squared, that is square root of pi over 2 squared, that will give us pi over 4, right? When you square each of those terms, and then when we're done with that, we're going to subtract. When we substitute 0, notice that this is going to be secant of 0, right? Secant of 0 is just going to be 1, because secant is 1 over cosine. That will be 1 over 1, right? Which is 1. Natural logarithm of 1 will just give us 0. Alright, great. So this is going to be 1/2 of the natural logarithm of, well, what is secant of pi over 4? You notice that cosine of pi over 4 is root 2 over 2. So that means that secant of pi over 4 will be 2 over root 2, right? Okay, but 2 over root 2 is the same thing as, let's put 1/2 of the natural logarithm of 2 over root 2 is the same thing as the square root of 2. So in fact, we can put our result like this, okay? or maybe if you like, you can rewrite it a little bit. Maybe since this is 2 square root of 2, we can rewrite it as 1 over 4 in the natural logarithm of 2, right? But whichever way you stop is still the same thing. Okay, all right, let's clean this and then solve another one real quick. Okay, so we are given another one here. So we have the integral from 0 to x of this function with respect to y, all right? Then we take the integral from 0 to 4 of the whole of this with respect to x. Okay, so looking at this function here, this integrand, we can just do that quickly by just starting off right from the inside out, right? So we start from the inside, we integrate this with respect to y. After that, we integrate with respect to x. And maybe let me just point here, stop here and just say there are times that we'll be given an integrand and trying to integrate it inside out, it could be very difficult. So in such cases, we would like to interchange, right, the order of integration, and we'll be covering that in our next video. Okay, but here let's see what we can do from here. Well, we are going to observe that this is with respect to y, so we are going to be considering this function with respect to x as a constant, right? So integrating this, we are going to have, well, the integral from 0 to 4. Okay, so this x is regarded as a constant. That means we will take 2 over x plus 1 out, right, as a constant, as I said. Okay, so we're now looking at y plus 1. That is 1 over y plus 1. When we integrate that, notice 1 over y plus 1 will just give us natural logarithm of y plus 1, right? Because you're integrating 1 over that. Okay, so this is going to be taken from 0 to x. That is with respect to y, and then you put the dx over here. Okay, so let's see what that will give us. Well, we put integral from 0 to 4 here. Okay, so this will substitute. So this is 2 over x plus 1. Now when we substitute x in place of y, right, that is the values of y, from 0 to x, substitute x here, we're going to have natural logarithm of x plus 1. Okay, we substitute 0, that will be natural logarithm of 0 plus 1, which will be natural logarithm of 1. Natural logarithm of 1 is just 0, so in fact this is where we are going to stop for now, right? So we can equate these two. Well, observe, let me rewrite this a little bit. We can factor out these two. We're going to have 2 times the integral from 0 to 4 of the natural logarithm of x plus 1 divided by x plus 1, and then we put the dx over here. Okay, this is nice, isn't it? Well, we can integrate this easily just by looking at the derivative of, let's see, if we differentiate this numerator, notice we are going to have the denominator. So in fact, let me rewrite this for that to be visible. So this is going to be 2 times the integral from 0 to 4 of 1 over x plus 1, right? Then multiply it by the natural logarithm of x plus 1, and then we put the dx over here. So notice that when we differentiate natural logarithm of x plus 1, we're going to have 1 over x plus 1. So that tells us that this result will be the natural logarithm of x plus 1 squared, right? Since the derivative of this term gives us a term that is multiplied, we'll just take the square of this term and then we divide by 2, right? Just like saying x squared over 2. So this term will be considered as a single term divided by 2, since its derivative is multiplied together with it, right? And then we take that from 0 to 4. Okay, so this and that will cancel. Then we substitute 4 in place of x. We're going to have natural logarithm of, well, 4 plus 1 will just be 5. So we have 5 there. Okay, and then we square that. Okay, and then we say substitute 0. That will just be natural logarithm of 1, which is going to be 0. So in fact, this right here is a nice place. Okay, you can just say natural logarithm of 5, and then you raise it to the power 2, or you can write it as natural logarithm squared of 5, right? Whichever one is convenient. So this right here is it, right? Okay, in our next video we'll be considering double integrals, where we'll have to switch the order of integration, and you will see how that is done. All right, but for now, thanks for watching, and please subscribe to my channel.